Okay, hello IB Bio students. All right, today we're going to continue with 9.4 and we are going to look at photoperiodism. So let's put on our thinking caps. So here's the essential understanding. The switch to flowering is responsible to the length of light and dark periods in many plants. So let's see how this comes about. So let's remember that the purpose of flowering is to allow this plant to sexually reproduce via pollination, fertilization, and seed dispersal. So then that means that most flowers are going to bloom when these pollinators are most active and abundant. And we know that these pollinators are most active and abundant in certain seasons. Some plants bloom in long day conditions known as summer, whereas other plants bloom in short day conditions, could be in the autumn or in the winter time, early winter time. So the critical factor that is responsible for flowering is the length of light and dark periods, and this is what we call photoperiodism. And this length of light and dark period is detected by these leaf pigments called phytochromes. So we find these pigments in the leaf, and these pigments are going to be able to tell the plant when there's lots of light or when there's less light or prolonged periods of darkness. And it's that response of that plant to the relative length of light and darkness that we called photoperiodism. So there are two types of phytochromes. So there are two types of leaf pigments, two forms. There's an active form and there's an inactive form. So let's see how these two forms come about. So the inactive form is known as phytochrome PR or phytochrome red, and the active form is known as phytochrome PFR or phytochrome far red. So let's see how these levels are affected during the day and the night. So we see here that phytochrome PR or phytochrome red is converted into the active form when it absorbs red light. So here we see in this red line here, we see phytochrome red is absorbing red light. That happens to be somewhere around 660 nanometers in the action spectrum. Okay, and that's why it's called phytochrome red, because it absorbs red light. So it is converted into the active form known as phytochrome far red or phytochrome FR. Now this phytochrome FR can be broken down back into the inactive form when it absorbs far red light. Far red light of approximately 725 or 730 nanometers. Okay, so this is happening simultaneously during the day. Okay, because there's light during the day, right? Now, additionally, the active form of phytochrome PFR, right, phytochrome far red, can also gradually revert to the inactive form when there's an absence of light or just total darkness. So in the dark, right, in the nighttime, or if you purposely cover a plant, there is going to be a slow reversion of PFR to PR. Okay? So then what does that mean? When the sun is out, sunlight contains more red light than moonlight. When the sun is out, then that means that the levels of PFR are going to rise. So during the day or long days, right, you're going to see an abundance of PFR or the active form of this pigment. As the active form is reverted in darkness, right, we see that the inactive form is predominant, or we see high levels of the inactive form during the nighttime. Okay? So high levels of PR at night, or we can say low levels of PFR at night as well, right? Or high levels of PFR during the day. Okay? All right, so let's continue. So photoperiodism is actually determined by the active form of PFR. Now, I just finished telling you that PFR, there's going to be high amounts of PFR during the day, right? And low amounts of PFR during the night. So it is that active form of phytochrome far red that is going to be the cause of flowering. Now, plants can be classified as short day or long day plants, depending on when they bloom. However, the critical factor in determining their activity is the night length. So how long is that night? And I'll explain why in just a moment. So here we see short day plants. And short day plants mean that they have a long night, right? So short day, long night. Now, one thing you need to know about phytochrome far red is that it acts as an inhibitor to short day plants. So short day plants are not going to flower if PFR is in abundance. So in order for these short day plants to flower, PFR, which is an inhibitor, needs to be found in low levels. So then that means that PFR needs to revert, and remember this is the active form, PFR needs to revert to the inactive form, right? And we know that this happens during the nighttime. So PFR reverts to the inactive form. So now at night, you're going to have low levels of PFR. And therefore, these short day plants can flower. Now, I just finished telling you also that the critical night length is the critical factor. So in order for this process to actually happen, the night needs to be long. And it's got to have a critical night length to allow this process to occur. Okay, so this long night is going to allow for phytochrome far red to revert to its inactive form, right? So now, due to this long night, we are going to end up with low levels of PFR. Okay, and now these short day plants that are inhibited by PFR can now flower. Consequently, long day plants have a short night. And we think of this to be summer, right? Short night, long days are summer. Now, PFR has a different effect in long day plants. Phytochrome far red activates flowering. So you want the PFR levels to be high. So you don't want this process to happen. You want a short night because you don't want to inactivate PFR. So because the days are long, right, you're going to see more of the inactive to active conversion of PFR. So actually now it's going to go the other way, right? So during these long days, you are going to see high concentrations of PFR. But that's good because you must have high concentrations of PFR for these long day plants to actually flower. Okay? And that can only be achieved if the night length reaches that critical length. So allowing for short nights and long days means that you're going to be able to reach that high accumulation of PFR. So the mnemonic here to help you with this is Sid the Lad. Short day plants are inhibited by PFR. So you want to exceed the critical night length to allow for this reversal process and drop the levels of PFR. Long day plants are activated by PFR. So you actually want to have shorter nights. The night must be less than the critical length. You want short nights so that during the day you have an active production of PFR. Okay? So how do horticulturalists, these are scientists that work with plants, how do they induce short day plants to flower out of season, or the other way around, long day plants to flower out of season? So there's some methods that they use. So let's look at them. So horticulturalists can manipulate the flowering of short day and long day plants by controlling their exposure to light. So remember that it's all about the critical night length. Okay? It's all about that critical night length. So let's move this up a little bit more here. All right, so let's start with these long day plants. So long day plants, remember, require periods of darkness to be less than the uninterrupted critical length. So these long day plants have a short night. So they need to have a short night, right? Because PFR, phytochrome far red, acts as an activator. And this is available during the day. Or most of it gets converted during the day. It's induced by sunlight. So notice that if you have a very long day right here and a very short night, then that critical night length is not achieved. So during that long day, you can produce a lot of PFR. And that's going to allow for blooming of this plant. If the night length exceeds that critical night length, then you're not going to stimulate enough PFR for this plant to bloom. So the plant is not going to bloom. But what can you do to these long day plants when there's a lot of darkness? So these plants, for example, carnations, if you want to have them bloom at a season when there's these long plants, what you do is you trigger flowering by interrupting that critical night length, which is what this is doing. And you interrupt the critical night length by exposing the plant to a light source, like shining a flashlight or putting them under the light at a certain time during the night. So then that means that this critical night length here is not going to be achieved because now you broke that continuous darkness. And if that happens, the plant is going to be able to bloom, right? Because the critical night length was not achieved. You ended up with more light and the plant bloomed. Now let's look at short day plants. short day plants means that you have a long night. If you have a long night, that means that you're going to end up with low levels of PFR. But that's a good thing, right? Because PFR is an inhibitor of these short day plants. So let's see what's happening with these short day plants. These short day plants, notice that will only bloom during short days. So here is the short day and here's the long night. So because there's a long night here, you've decreased the levels of PFR. So now this plant can bloom because there's low levels of that inhibitor. They won't bloom when there are long days, right? Because there's too much PFR, too much inhibitor. So they won't bloom there. And let's say that you are also manipulating these in the laboratory, let's say, right? Well, you can actually get these short day plants to bloom if you put them in the lab and you just cover them with an opaque black cloth for approximately 12 hours, right? So these chrysanthemums, which is a good example, the mums that you see in the fall, they're a great example of these short day plants. They can bloom in the summer if you cover them inside the laboratory, right? And you force them to bloom because you increase their night levels, critical night levels, okay? Now, what happens to this mum, and let's just pretend this would be an interesting experiment. What would happen to this mum if during the fall, right, where there is a critical night length that could potentially be achieved, what happens if you interrupt that critical night length? You wake up in the middle of the night and you start shining a light on this mum. You interrupt it. Well, then this mum is not going to grow. It's not going to flower, I mean. Okay? So that's how you can manipulate the flowering of these short day plants and these long day plants. So this was, this topic I think would be the most challenging topic right now. So make sure you spend some time reviewing these concepts. And if you need to go back and watch the video again or stop at different times, then I recommend you do so.